In previous videos, we've talked about using dry steam to clean and sanitize our watermill. We received many comments asking what the heck is dry steam? How is it different from regular steam? And why can't we just clean the watermill with a normal pressure washer? To answer those questions, I went to BG Clean, one of only a few companies in the UK with a whole range of pressure washers, from light commercial cold water up to the dry steam we were looking at using. I thought we wanted to use dry steam for cleaning the mill, but it turns out I got a few systems mixed up, and it turns out the machine we're looking at is actually a low flow saturated steam system. I had the chance to try out several different machines. The dry steam systems are pretty fantastic, but the area cleaned in each pass is just too small for the watermill. They'd be highly appropriate for cleaning a statue, but not the 750 square meters of wall we have to work on. The jet of a dry steam system is only about 5 millimeters wide, and you can't move too quickly with it. If you cleaned our walls at around 15 millimeters of travel per second, it would take almost 4 months to clean the walls. If you never slept or took any breaks, using one of the most powerful dry steam systems on the market. We've been looking at a couple of different machines, primarily the DOF from Stone Health, Mazzoni's Saturated Steam, and BG Clean's Red Mist. I bought a stone and a few slates from our watermill. I didn't want to bring more for testing the cleaning systems on, as there are really not any loose stones just lying around. Though we have a limited area of stone to work with, we're going to try out different types of pressure washers on the stone and slates to see how they compare to each other. Before we talk about how my expectations of how a petrol-powered cold water pressure washer and the Red Mist system took a massive hit, we need to talk about the different kinds of pressure washer systems. Pressure washers come in a variety of sizes and mechanisms. There are low-cost domestic pressure washers that use cold water, and we already own one of these. Then you have high-pressure, high-flow commercial systems, which also use cold water. Systems that can warm the high pressure water, systems that get the water beyond boiling temperature, and moderate pressure systems with low flow rates and very high temperatures. Finally, you have machines that can produce supercritical steam at much lower pressures. Most of these can add chemicals or detergents into the pressurized water, allowing them to clean more effectively. Using hot water allows for more rapid removal of deposits, as the high temperatures help to break down the deposits and accelerate the speed that any chemicals used do their job. Dry steam pressure washers use high volume of supercritical steam. Think of it like industrial steam that steam engines run on. It's not the wet, condensing steam that you have from a shower or boiling kettle. It's created by having a sealed vessel with water in it and boiling it at very high temperatures, so you have steam without any atmospheric air in it coming out of the nozzle. Dry steam pressure washers work at a pressure similar to that of an air compressor, rather than 10 to 20 times that pressure as you might be used to in a regular pressure washer. Their advantage is incredibly high temperatures, between 150 and 180 degrees Celsius. For those of you who don't understand Celsius, that's 423 to 453 degrees Kelvin. High temperatures are able to deal with most problems that face conservation cleaning, mineral deposits, organic deposits, and graffiti, without the vast quantities of water used with a regular pressure washer. This is where the DOF and Red Mist are similar to dry steam, and somewhat where my initial confusion began. Both the DOF from Stone Health and Red Mist system that BG Clean make operate at a similar temperature, around 130 to 160 degrees Celsius, which is where the cleaning power comes from. Where it differs from dry steam is that it operates on water pumped through a heat exchanger at very high pressures, like any other pressure washer. The pressure is less than even the least powerful domestic pressure washer though, and at very low flow rates. On contact with air, the water rapidly evaporates, generating giant clouds of saturated steam. The volume of water is so low that it's very gentle on materials. When we compare the high pressure, high flow machine to the Red Mist, the results were drastically different. My expectation was that the Red Mist would damage the slates from thermal shock, but in fact it didn't damage the slate at all. The cold water system tore the slate to shreds. There are tracks on the top of the slate from where the water jet hit the surface. It also cracked the slate from front to back down its entire length. And the ground was covered in debris. We then cleaned the back of the same slate with the red mist system and couldn't cause any damage or make the fracture down the slate get any worse, despite holding the nozzle directly on the crack and weak points in the slate. The difference was purely down to the higher pressure and massively greater flow rate of the petrol-powered system. When cleaning the sandstone, my expectations were again incorrect. I had expected the cold water system to abrasively remove the top layer of stone, exposing clean stone underneath, so the stone would look visibly cleaner. Despite blasting some chunks off the sandstone, the stone did not look as clean as when cleaned with the red mist. I was really surprised by this. We tried both systems on the side of the stone, as this is where the fragile layers of stone are exposed, and also the orientation of the stone on a wall. The pressure washer visibly damaged the softer areas of the stone, to the point where you can feel that a 1/4 millimeter or more of stone has been removed, leaving low spots. This was in a single, quick pass. The red mist system was not able to create this damage. I deliberately did not clean all the way to the end of the stone, as I wanted a comparison between where I had cleaned and where it was untouched. Despite holding the red mist blasting at one point of stone for over 30 seconds, there was no visible or tactile difference to the stone at that point. The area which I didn't clean was the most interesting of all to me. Compared to the end of the stone that was untouched by either machine, it's about 50% cleaner from just having the steam rushing over it while the nozzle was cleaning the stone nearby. Our final victim was a piece of wood that was lying around in the BG Clean warehouse, thoroughly coated in diesel and dried oily gunk. The cold water pressure washer tore this to shreds. Just holding the washer over one section of the wood for a few seconds took over 10 millimeters of material away. The red mist system wasn't able to break the surface of the wood, though it was much slower to remove the material on the wood. The wood still had a stained colour, but the deposit was gone from the surface and the surface was undamaged. What really surprised all of us was how quickly the materials dried after cleaning. It was just below freezing when we were testing the machines, and the runoff was freezing on the ground, making things very exciting when carrying expensive cameras. After cleaning with the red mist, the slates and stone started drying immediately, and with just a little bit of compressed air blown on it, it dried completely in seconds. On the other hand, after cleaning with the cold water system, it took minutes to dry the material when placed in front of a big industrial heater. The difference in volume of water used was quite apparent, as well as the volume of water which actually stayed on or soaked into the material. With the red mist, most of the water was evaporating away before contact, and quickly evaporating after contact too. The high temperature of the water meant it just couldn't stick around despite the cold ambient temperature. In our watermill, we have a lot of mold, algae, fungus, and other biological growth on the walls. The kiln is also full of pigeon droppings. None of this is particularly great for our health, so we need to clean it and make it safe to live in. Our watermill is also a listed building. It's 250 years old and the oldest mill in the area. With a listed building, a delicate conservation approach is required to ensure the building is preserved for future generations to enjoy. None of these systems are cheap. They are not intended for domestic use and are typically either rented out or used by contractors who do this work all day, every day. So why wouldn't we use another cleaning method for our watermill and save a load of money? Chemical cleaning can be ruled out pretty quickly. We already have a damp problem, and the high volumes of water required to rinse any chemicals out of the building's fabric is not going to help the issue. We're also on a water course, so have to be very careful about what chemicals might make their way into the water. Generally, pressure washers can be ruled out for similar reasons. We don't want high volumes of water getting used in the mill. All the wood in the mill is already rotting, and we don't want to make it worse. A good commercial pressure washer uses around 900 litres of water an hour. That's enough to fill an 8-person hot tub every 2 hours of use. In addition to the volume of water, the pressure is also an issue. Our mill, like many historic buildings, is built from sandstone. As I saw from our quick test on Sandstone, you can do a lot of damage to the stone in just seconds with a regular pressure washer. Understandably, we don't want to obviously damage the stone in our building, or cause pitting or other issues which will not create visible damage for a couple of years. The saturated steam and dry steam systems can't damage the stone. They just don't have the pressure or flow rate for it. Despite this, it's still able to clean the surface of the stone and other materials we have in the mill better than the domestic pressure washer and safer than using chemicals. Additionally, for our application, the high temperature is fantastic. We have so much biological material in the stonework of the mill. The high temperature is able to completely kill any mold or fungus growth and spores while also destroying any bacteria or viruses left from the pigeon droppings. Any chemicals we use for this would be an environmental disaster for the waterway next to the mill and could potentially damage the stone as well. So, despite the cost, the high temperature, low volume steam washer will give us the confidence that our mill is actually sanitary and safe to be in. We don't want ourselves or our 2-year-old or our dog to get sick from the nasty stuff on every surface of the mill. We also don't want to destroy the environment around us or damage the building in our quest to make the place less gross. If you have any questions about the pressure washer systems or the watermill, please leave a comment and we'll do our best to answer your questions.